Welcome back, Chemistry 30. This is the last section in the MS unit, MS 3.6, Organic Functional Groups. So at the very start, we talked about, for the most part, hydrocarbons are non-reactive unless they have an additional piece added to them, such as a functional group, which tells us how it functions. So we're going to look at various ones here, or you're going to look at them. Identify various classes of organic compounds based on the little group that's attached to them. So we'll look at halocarbons or haloalkanes, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, and amides. And we'll talk about where in real life are these used, why are they important. So functional group. The term functional group is used to refer to the part of the organic molecule where reactions tend to occur. These functional groups each undergo characteristic reactions, and the same is true for all other functional groups. Each kind of functional group often undergoes the same kind of reaction in every molecule, regardless of the size and how complex it is. Thus, the chemistry of an organic molecule is largely determined by this little attachment, this little functional group that is there. So what you're going to do here, we're going to research all of these. I'm going to do the first one with you, though. So the key things that you're going to have to do is draw a structure. Draw at least 3 examples. You should be able to easily find that. Nomenclature, a quick overview in terms of how do we name these. Properties, list at least one property. It could be such as polarity, solubility, boiling point, etc. that makes it similar or different from other molecules. And of course, one of the good ones is an application. Where is this used in real life? So what we'll do is we'll do one together. And to do these, you can either use the internet, Google them, or if you want, you can grab a chemistry textbook from the class, because there are quite a few of this can be easily found in there. So it's up to you in terms of what you would like to do. All right. So here, the structure. So we can draw what they look like, draw a couple of examples. So here, halocarbons or haloalkynes. So halocarbons contain halogens, as you can expect. And those, of course, are the group 7A elements. So the group 7As, of course, include fluorine, chlorine, bromine, and iodine, as well as others. So one example is this one, and the way this one's named is trichloromethane. So the trichloro means I have 3 chlorides, and one single carbon is methane. Another one I could have another chlorine, except this time it's attached to a benzene, and it's called chlorobenzene. And another one. I think I got these from the textbook. I can't remember. It's either I either got it from the textbook or online. So HHH. Here we have an F. Here we have a Cl. Here we have an H. So you have a butane, right? So it is partially butane. But we have other things happening here. Now, if I number it this way, 1, 2, 3, 4. So 2 chloro, 3 fluorobutane. All right, so that's what we got. In terms of naming these, how are these named? So you can see here that the prefix is chloro, and there we go, no L there. And iodo are used for naming. And also if there are more than one alphabetical order is used. Okay. Let's look at properties. I'm having trouble with the sunlight here shining in. Properties. So boiling points increase as the halogen changes from the very small ones to the very large ones, etc. And of course this is due to increased number of electrons shifting around and making temporary dipoles. So of course, good old London dispersion forces. Dispersion forces. And lastly, applications. So there's quite a few different ones here. I'll name a couple. Used as solvents and cleaning agents. Since they dissolve, because for the most part it's nonpolar, so they dissolve nonpolar molecules. Okay, so that's one thing that they do. Another example, if you have long continuous chains of carbon with fluorines attached, of course each of these fluorines have a bunch of electrons. That is Teflon, or as it's known, polytetrafluoroethene. And it's a plastic often used in carpet. Yes, plastic used in carpet to increase its resistance to staining. So it prevents stains from happening due to these long chains that are included there. All right, so that's it. So you can go and look at alcohols and ethers, etc. And again, if you want to borrow a textbook, you can, or otherwise you may want to Google them. So for structures here, make sure you do at least 3. And then naming, try to go through quickly how you name it. And then over here, at least 1 property. And then here we'll say at least 1 application as well. So if you could do that, that would be great. All right, and this will be a hand-in assignment. So hopefully make sure you have this copied out for the first one. So we did this one together, easy marks, and then complete the rest. All right, we'll see you again.